Welcome to qnawire.
Okay, here we have a chain rule problem, and it looks like there was a shortage of numbers for this problem, and so somebody had to write it with a whole bunch of letters. But we're going to use all the same concepts and just apply all the rules that we already know. So to find the derivative, the outermost layer is the p power, and so we're going to bring down the p and raise the inside to the p minus 1. Just like if that was a 3 or a 4, you'd bring down that number and you'd raise it to the 1 less power. Now we need to multiply by the derivative of the inside. And the inside is the sum of two terms, so we'll find the derivative of the first term plus the derivative of the second term. So now we're finding the derivative of 2r times a to the rx. And so 2r is just a constant. Our variable here is x, so all the other letters are constants. So we leave the 2r, the constant, and we multiply it by the derivative of a to the power rx. Well, remember the derivative of a to the x is a to the x times natural log a. So if it's a to the rx, using the chain rule, the derivative would be a to the rx times natural log a times the derivative of rx, which is r. So we get a to the rx times natural log a times r. So that takes care of that. And then we have plus the derivative of n, but n is just a constant, so its derivative is 0. So we're actually not adding anything to that. Now let's see if there's anything we can do to this to make it a little bit nicer and neater. Well, I suppose we could multiply the p and the 2r and the r together. So we have 2r squared p, and then we have the natural log of a as well. And then we have the big quantity here. We'll just rewrite it, 2r a to the rx plus n to the p minus 1, and we still have the a to the rx to write. So a lot of it was just copying the same thing all over again.